Good afternoon, Dr. Laurie. My name is Leif and I'm going to be speaking to you about the testosterone molecule. It is principally responsible for many important bodily functions, like our mental and physical endurance, development of male characteristics, overall health and well-being. The list goes on, but that's not particularly why the testosterone molecule is important to me. Well, maybe the male characteristic side, but I love this molecule as it has permitted me to look like this. This molecule has greatly increased my bone density, and most appreciatively, testosterone has been a potent multiplier of lean muscle mass and strength. It is a steroidal hormone, not dissimilar to estrogen, produced in the human body from cholesterol, a very closely related and similar shaped molecule, and requires a series of complex reactions involving proteins and enzymes to synthesize. It's considered quite a large molecule with an atomic mass of 288 units and consists of very few chemical reactive areas. This molecule's primary method of action is not to react but to bind to hormone receptors on target cells, acting more like a chemical key, triggering many important bodily functions. Putting the molecule under the microscope, it is a chemical formula of 19 carbons, 28 hydrogens, and just 2 oxygens, and exhibits a tetracyclic shape, which becomes key when describing this structure and its attributes, as this shape produces 4 separate carbonic rings attached to one another, allowing a high degree of rigidity in the human body and prevents molecule flopping. This structure is deemed a solid at room temperature. The substance's shape is also classified as stereogenic, meaning it can only be mirrored, as not all carbon atoms are bonded to 4 other entities. As it's said and seen, the steroid skeleton is nearly planar, with the molecule being predominantly carbon-hydrogen single bonds and carbon-carbon single bonds, with 2 methyl groups, which contributes to a low polarity and proving the molecule to have a low solubility, as it has only 2 functional groups: the carbonyl group, double bonded oxygen, and the hydroxyl group, oxygen-hydrogen. It's these 2 functional groups that allows the molecule to be distinguished, its dissolvability in water, and permits molecular tethering, enabling development of different oral steroids. The overall configuration permits a stable state molecule with low polarity and low interaction with other substances due to these non-polar physical properties. In fact, the testosterone molecule is quite lipophilic due to its low solubility in water and high solubility in fat. Thus, it's the testosterone molecule's physical properties which justifies these characteristics as an overall non-polar molecule.